Hello, my name is Irfan. I'm a maker. You're watching an episode in my Beginner's Journey series, Designing and Constructing an Arabic Oud Instrument. I'm very passionate about the old Nahats, and I spent some time digging up info, whatever I could find online, specific to how the Nahat luthiers actually went about designing and building these beautiful instruments. In a recent episode that I published, episode number 5, I explained some fairly powerful concepts pertaining to where the Oud geometry comes from. So same way that builders and makers have been building for thousands of years. In that particular episode, I had used a reference paper that was published in FoMRHI Comm by John Downing. FoMRHI is the Fellowship of Makers and Researchers of Historical Musical Instruments. And I used that paper and the details that was presented on that paper, and I reverse engineered it, and I put it to an actual design, and I captured it on video. So in episode 5, toward the end of that episode, I showcased that, and I debated whether to separate that out as a separate episode, and this is what I'm doing. So this episode is where I just separate out that design and just showcase it as a standalone. I hope you find some value in this work, not only what I've presented, but more importantly, what John Downing analyzed and published in the FoMRHI Comm's research paper. I will link to that paper in my description, and here's the video that I made following the information that John presented in that FoMRHI Comm. I hope you enjoy it. So continuing on with the modeling and design of the Nahat Oud using the 3-4-5 Pythagorean triangle, the triple triangle. Although this looks complicated, but at the end it is pretty straightforward, and it does start making sense, right? So I'm gonna try and see if I can provide an explanation. And again, the best source is John Downing's paper that I referenced earlier, and then an alternate method to using the pins to get this elliptical shape correctly on both sides, right? So this elliptical right here, it just gradually smooths into the base of this profile, okay? So I believe the best way to understand this model is if you literally break the top curve from the bottom curve, right? Now this drawing is on a scale of half. So my design parameters are the width of the bowl. Actually, I wanted to use about 35.5-ish, but just to keep the math simple, I opted to just go with a maximum width of 36 centimeters, right? So that's the maximum width of the bowl, right? And the depth is half because I am doing a symmetric design. So the depth of the bowl is going to be 18 centimeters, and the length, which I still have to work out, but the length I want to keep around 488. So this is not the neck. This is just the curve. The neck is going to be down here. So this will come across. And then this length is going to be 488 millimeters. That's my intent. So the best ways to go about doing this is you take a piece of paper. I would have liked to make this to scale, which would have been pretty good. But if you have the resources to make it to scale, go for it. If not, then based on what you have, you can do half or even a quarter. Quarter may be iffy. I don't know. I opted to go half. Okay. So on the paper, you just get the center line, right? Just get these center lines. And what we are trying to do here is just trying to get the A and the B for this triple triangle. So this is the A, this is the B, and that's the hypotenuse, right? So your A is 3 units, B is 4 units, and the hypotenuse is 5 units. And that is the basic 3, 4, 5 triple. Okay. So now if you say that the width of the bowl is 36 centimeters, you divide it into 4. So each unit then is 9 centimeters. In my case, since this is half scale, so this is 4.5 centimeters or 45 millimeters, right? So that's 1, 2, 3. And don't worry because it's going outside the side of the bowl. I'll come to that in a minute. So A is 1, 2, 3, and B is 1. So this is 1, 2, 3, and 4, and hypotenuse is 5. So 3, 4, 5. Okay. Now once you have that triangle sitting there, you pick a point. So if you're drawing this side of the upper curve, actually you're going to extend the curve all the way down, but if you're drawing this side of the curve, you pick this point, which is the third unit, open up your compass all the way to the hypotenuse, so the 5 units, and then just lay out the curve. Okay, so this curve is going down here. Then go on the other side, do the same thing. So 1, 2, 3. So on the third point, open up the compass to 5 units, which is the length of this hypotenuse, and lay out this curve right here. Okay, so this will give you a pretty good profile for the top of the bowl. Now, I did quite a bit of research. So this is the this design is circa 1910 Nahat, right? And I'm not really, John Downing used a different model, but I just carried over that concept to the design parameters that I was using, right? I don't believe the basic concept or the methodology changes. It's just the how you define what your maximum width and the depth and then the length, right? But the process and the concept and the methodology remains the same. That is what I believe, right? So once you have this profile done so far, then to define, so again, come back to this arcs down here. If I was to leave it here, right? So for the base of the bowl, right? So this arc right here, right? I could just merge this into here, but see how this will look really awkward. This will come out really awkward. It comes down here. So this arc actually is all I did here is I did 6 units, And from this point, let's call it N. I think that's, yep, we can call it N. And I think that's the same reference that John Downing has in his paper. You go 6 units and you make this arc down here. Now, obviously, the side of the bowl will not smoothly join this arc. So I can make it work, but it will be more kind of circular. I want an elliptical shape. So to get that elliptical shape, I use the pin method, pin and thread method, which works, but it was a little clunky. So John had a reference in one of the posts on MikeOuds.com, where he used a slightly different approach, which I like much better. Again, as I stated, I did enough research on these different sources to see what my best options are going to be here, right? So in order to get this profile for the bottom part of this bowl, right, what he suggested as an alternate option was to draw the square, right? Now, what is the square? This is the width of the bowl, right? So as you can see, this is the width of the bowl, right? So half scale, so my actual width is 36 centimeters, half scale 18 centimeters, 18, 18, 18 centimeters, right? Then step 2, draw 2 diagonals, okay? And that's right at the center of that first triple triangle is where those diagonals are gonna meet, okay? Now step 3, so you notice where this curve, which we drew originally from this point, and then this curve, which we drew from this N, 6 units. So these two intersect at this point E, right here, which is close to actually this diagonal line. So if I can zoom in a bit, so it is not on the diagonal line, but it is pretty close. So from this point, you open your compass to the center line, and you draw you this arc. Okay, this arc. So again, from this, so this intersection point is this curve that you drew from N, 6 units, and this curve that you drew from Z or whatever, right, 5 units, right, where these two intersect is your pivot point for the compass. Open the compass to the center line and then draw you this arc, okay? This arc will intersect, as you can see, this point F, it intersects that diagonal, okay? Then you pivot your compass off this intersection point, which is F, and just open it. You'll get a feel. You open it right to this original curve. So this curve, right? This curve, right? You open it right to the original curve. So it's gonna, in my case, it was about 20 millimeters from this center line. So 20 millimeters south, okay? And then you gradually just draw this curve, right? So you gradually blend this, into the low, into the top of the base or top of the bowl profile, right? And boom, it'll meet right here. Do the same, repeat that same on the other side, and it meets right here, right? And eventually all these extra lines I will erase, and I will just keep the basic profile here. So there you have it. It's not that complicated. Now again, the deep mathematics behind it, I haven't dug that deep. Maybe someday but this is just the practical application. And unfortunately, I just found out recently that John passed away in 2024, but his legacy lives on. If you go to mikeouds.com, he has been an active member on that forum for a long time. So God bless you, John. So anyway, so now the next step here is I got to still define the sound holes, right? I'm probably on this design similar to the 1910 Nahat Oud. I'm probably just gonna go with the main sound hole. I mean, that minimalistic design, I just love it. Actually, Richard Hankey, in one of his videos on his YouTube channel, he plays that 1910 Nahat. Beautiful, beautiful oud. Beautiful oud. So you might want to visit, take a look there. But I'm leaning just to keep one center sound hole. So I got to do that. Then I got to decide where I'm going to cut this off for the neck block, and then complete my profile. Important. If you go online and search for John Downing, Geometrical Analysis of an Old Nahat Oud, you will find this paper that he has published. And this is the baseline reference I'm using for my version 2 design. According to what he has published, apparently there is not too much that has survived from the notes of the Nahat luthiers, and that's why he's stating that this is proposed geometry, which he believes was actually employed by the Nahats. If in addition to this paper, if you go to mikeouds.com, it's an online forum. John is a member of that forum, and you will find a lot of extremely talented luthiers and individuals, and a lot of information there. Lots and lots of extremely valuable information there. And it's an extremely helpful community. So, yep, let's see how this version 2 design goes. I'm looking forward to completing it and then comparing to my version 1. And then moving on with the next steps in my build process. All right. So the way I did this is I just used those 2 pivot points, and I put my pencil down here, kept that string taut, and then I just traced this curve. So if you look at it, this is elliptical, right? And I am happy with the shape, the way it's coming out on the base of the bowl, right? I've got to do it on the other side and then smooth it out the best I can.